when I first started Intel, I just thought Intel was CPUs, even though the very computer I saw my application from had Intel networking, Intel SSDs, and the CPU. So this is just kind of a quick overview of some of our data center products to bring awareness that you've probably heard of our products in these other forms, but you may not really realize how much is out there. I know that we are more than a CPU, but I have to start with CPUs. So our data center portfolio is rather large. I will not read this to all of you because I'm sure most of you can read fairly well. But I will talk a little bit about our new processors. That would be our Intel Xeon Scalable platform. That was what replaced our E5 and E7 processors before. So these are actually processors which help drive high performance computing. And by doing that, we have things built in, like we've increased our AVX from AVX2 to AVX 512. We've reduced the latency within the CPU by going to a mesh architecture instead of a ring architecture, so communication between cores is much faster. And when it comes to communication, we also have the UPI, or Ultra Path Interconnect. That's how CPU 1 talks to CPU 2. So if you have your storage hanging off of CPU 2 PCIe, CPU 1 needs a way to talk to it, and that is the bus that gets it there. And we do also have select models for those real HPC needs that have Omni Path built right into the CPU, saving you PCIe lanes and a little bit of cost. Quick Assist technology, that's something that once was an add-in card, is now built into the chipset to provide compression. So if anyone's looking to do projects where they need to do encryption or anything like that at a quick level to help bring it out of software, they can do it directly in hardware. So AVX is one of those things that people look at it and say, my CPU is going slower with AVX than it is without. That is because we have registers dedicated to AVX. So to provide power to them, we have to slow things down because there's a limited amount of power, limited amount of heat dissipation. But as you can see, as we move forward in AVX, the impact performance here on the right, or actually that'd be your left, shows that even though we have reduced their speed, we are increasing in the performance of it, and also we've decreased the amount of energy it takes to make this happen. This gets very technical, so I'm going to fast forward through it. And one of the real benefits of AVX is artificial intelligence, or deep learning. Now, I know most people, when they think of artificial intelligence or deep learning, they think of graphics cards. And rightfully so. They do a great job, but this is a case where one size does not fit all. There will be certain applications that will run faster on graphics, and certain applications that run faster within the CPU. Now, we did a test on the it's listed here on Voelker. Make my notes a little bit larger so I don't lie to you. We did a test where we went to a third party, the Amazon Web Service, and we started instances, one on GPU and one on CPU alone. And all we did was included our Intel Math kernel library into the situation. And in doing so, by optimizing the code for CPU, we were actually able to perform faster than the graphics card was able to do. There's a link here that's actually going to be something that you'll be able to see online a little bit later if you want to look into it, or if you just search for on Fuzzilla for the Intel Web and Amazon Web Service, you'll be able to see it all there. So it's third party, it's not Intel propaganda or anything like that. I did mention we do have Quick Assist technology for encryption. So we have a little bit of information on that. That basically offloads some of the pressure from the CPU and allows you to run these applications much faster. So I'm going fast through this, so I apologize. We have our Omni Path architecture is just a very low latency way of performing network transactions. So if you have those HPC needs where latency is the real detrimental to your performance, this may be something that you want to look at and see if it's worth your time. Now, Omni Path, which is the Intel brand of this, is not the only game in town. We know that, and there are benefits to it that we're hoping that if you have these needs, you'll be able to realize with Intel, you can actually save money, enough money to actually buy more compute power. And the reason for that is our switches have a higher density, so it takes less switches, so you can take that extra money and pour more into compute hardware. Now, since I do data center stuff, I was asked to talk about our storage solutions as well. So we'll start with what everybody knows, which is typical NAND. Now, NAND comes in multiple form factors. We have our standard M.2 adding cards, and you may notice there's a very long one here on the far, your left, your right. That is the ruler form factor. We put out, I believe a year ago, that we're creating this ruler, and we're going to have 1 petabyte of flash storage and 1 U of rack space. That is incredible density, and our first generation of it went to 256, but everybody said, 256 is nice, but I really want 1 petabyte. So we're holding off on selling the first generation of it, which had proprietary connectors in it, and we're going to go with an industry standard connector in our second generation. So when this does come out, you will see that we will hit 1 petabyte of storage and 1 U of rack space. And to put that in perspective, right now, if you wanted 1 petabyte of flash storage in a rack, it would take almost the entire rack. So you're going to save money in cooling, electricity, and density. Now, we have multiple different solutions for whatever your needs are. Now, I understand that these links on the bottom will not help you because when it's online, they won't work. But we have a page called ARC, so arc.intel.com, where you can look up all of our products and see what the specs are and everything. Now, we do have different solutions for your different needs. And if you look through this, we have our 4500 series, which is our 4th generation of controllers. And they have, we're typically around 1 disk write per day. And we have our 46, which are 3 disk writes per day. And one thing to remember with this is if you're looking at our client solutions with SSDs, and you're trying to put them in a server solution, those are not rated for 24/7 operation. So you may run into issues later if you were to try to use a client drive inside of a data center application. Our data center drives are all rated for 24/7 operation, and they have what's called power loss imminent circuitry built into it. That protects your data. If there's a power loss, it also helps protect your data against silent data corruption. Silent data corruption is something that can be very hard to acknowledge is there, but the way that we do our testing, we actually make conditions 10 million times worse than what they would experience in a server to make sure that our drive would be able to recover from silent data corruption. Now, NAND technology has been around for a very long time, very well established. Everybody's trying to get larger, they're trying to get less expensive, and there's a limit to how fast they can go. So Intel and Micron joined together and they made what's called 3D Crosspoint. Now 3D Crosspoint is the base media. So once you put all the secret sauce in it from Intel, 3D Crosspoint becomes Optane. Optane, which I'm sure most of you have already heard about, is a completely different media. If you look at the numbers on paper, the read-write performance very similar to NAND. But one thing to look at with this is when a drive is tested for read or write, it is tested, that's all it does. It's 100% read, 100% write. And the IOPS are actually registered at a Q depth of 128. And that is the JEDEC standard. Most data centers will not hit a Q depth of 128. So that's like saying my car will go 200 kilometers an hour, but I live in the city. So what? you're not going to get from stoplight to stoplight at 200 kilometers an hour. So what's going to be really important is the acceleration. And that's where Optane comes in handy. It is much faster at the initial acceleration than NAND is. One of the nifty little things you'll notice here is there's a piece of memory up here. So with our new series of processors coming out, we're releasing Pcie Pass. Pcie Pass will be a DIMM module, so it will operate like RAM, and it will basically come in sizes of 128, 256, or 512 gigabytes. So if you put that, if you think about right now, if you're trying to put 512 gigabytes of RAM to a CPU, you need a lot of sticks. It's going to cost a lot of money. So this would be a much more cost-effective solution. One thing I would like to point out that by making memory out of the same media we put in our SSDs, that should also show you the right reliability of these SSDs. That we have so much faith in it, we're committing it to making RAM out of it. And our client side, which some of you also may be interested in, we still have Optane. We have an M.2, we have an add-in cards, and we have an U.2 form factors. So we have this handy-dandy chart to show you all the different models, what sizes they come in, what form factors they're in, and what their target audience is. But when I was talking about the maximum speed of your car, this chart over here will show you that a Q depth of 128 is really unreasonable to benchmark at. You'll need a synthetic benchmark really to hit those numbers. So we've actually compared it against our own P3700, which was a very nice drive, very fast, and at a Q depth of 16, that P3700 finally hit 100,000 IOPS. Now, Optane hits that at a Q depth of 1. So that's like, if you're sitting at, there's 12 stop signs, and you need to you can only go 60 kilometers an hour, but you have to stop at all 12 stop signs. If you can get to 60 kilometers an hour in 2 seconds, and it takes me 10 seconds to get to that same speed, you're going to get to the end much faster than I will. This is where latency really plays a part in being able to give reliable, quick performance. When you're tuning your databases, you want something that's predictable. You want to say, I can do this many transactions per second, but with NAND, if it's doing any background things like trim or any kind of cleanup like that, your controller gets a little overloaded and your quality of service starts to go a little off the chart, making it a little harder to get that reliable performance. So again, in the middle here, we went against our 3700, and the blue is the 3700. So you can see it was very stable for most of it, but it did falter a little bit, making it so it was a little harder to guarantee a certain level of performance. The gold on the bottom is our P4800X. That is our Optane drive. So it is actually much more reliable in forms of being able to tune for the performance you need. And I mentioned that when tests are done for maximum throughput on read or write, that's all it's doing. The way an SSD writes is not as efficient as it could be. So as the controller has to do work and move data from here to there, there's a lot of things that go on in the background. So as instructions line up, it has a lot of work to do. So the more data you push through it, yes, the higher IOPS go up, but the longer that line is for that data to go through, the longer that data has to wait to get processed. So the more load you put on, the higher IOPS, but the slower the performance tends to get. As you can see on this chart over here, Optane, again, gold bar on the bottom, doesn't matter what we threw at it, performance was very predictable, very reliable. So there are different situations where you'll see some improvement, and there are other situations where you're going to see a lot of improvement. So now in this case, we actually looked at the latency on mechanical drives. We're getting about 100 milliseconds. When we switched to the Optane drive, we hit down to 12 milliseconds of of latency in the top 99 percentile. Because of that, we're actually able to tune from 3,000 transactions per second to 17,000 transactions per second, which means you would actually have to buy less hardware to get the same performance level. And in doing so, one of the things we're looking at is a transition from Sata to PCIe. Some people do not feel comfortable with that because they don't believe that you can boot off of PCIe RAID. Well, we have built into some of our motherboards virtual RAID on chip VROC. And with that, you were actually able to use a CPU as a RAID controller card. You were able to boot from a PCIe RAID, giving you more flexibility and more ability to put this high performance equipment in your servers. So we're actually getting closer on the time here, so I'm going to go through it and finish up here. We have a lot of links, and no need to commit all these to memory now. Like I said, these pages will be available on their website. There are 3 pages of links here. So just so you can look for everything that you want to know, and it really gets some information. If you're looking at AI and you want to see that, where does Intel fit into AI, what kind of training we have, what kind of kernel libraries we have, will be sitting there. If you want to look at our products page, we have I put the ARC one on there. And by changing our names from E5, E7 to the bronze, silver, gold, and platinum lineup in Pearly, people got a little confused with, I had this processor, now what do I need? We know that would happen, so we made the second link from the bottom. We'll help you determine what CPUs you need. It's still unclear. The guys at Maguay can definitely help you out with that. And if they need more assistance, they can reach out to me, and we'll definitely get you pointed in the right direction. Like I said, there's 3 pages, so I'm just going to show you them there real quick. And we have a bunch of HPC information on there as well. And also stuff for comms, cloud, and enterprise. So please go check these links out once they're posted on the site. And we'll do it soon.
Thank you, Aaron. Pleasure to meet you.